Okay, so today we're going to continue on with Unit 2, this time Day 3. So if we open our notebooks to Day 3, our little journals, we're going to do a little bit of writing today. So if you enjoy your English class, then you will enjoy today and tomorrow or Monday. All right, Unit 2, Day 3, Conditional Statements. Listen. Rules of logical reasoning involve using a set of given statements along with a valid argument to reach a conclusion. Statements to be proven or proved are often written in if-then form. So all the sentences we're going to be writing for the next few days most of them will be in what's called if-then form. That is called a conditional statement. So if a condition happens, then there's a result. Okay, kind of like in science. Right? You test things out. You say, what if this happens? Oh, this was the result. Okay? So, for example, I could have the sentence that says two angles that are a linear pair are supplementary. Okay, we know they also have to be adjacent, but this is a true statement. Two angles that are a linear pair are supplementary. If I wanted to make this a conditional statement, I need to start with if the subject of the sentence, which we're talking about two angles. So if two angles are a linear pair, then what happens? That means they are supplementary. Now we know they're also adjacent, but I'm not going to add that into the sentence because it wasn't part of the original sentence. So I can't add additional information. Okay? So if two angles are a linear pair, then they are supplementary is how I could rewrite this sentence right here. Two angles that are a linear pair are supplementary. Okay? So we're going to practice rewriting some sentences. Rewrite each of the following sentences as a conditional statement. A, an angle that is acute will have a measure between 0 degrees and 90 degrees. How could I write that as a sentence? Yes?
If an angle has a measure between 0 and 90 degrees, then it is an acute angle.
Yes, that's perfect. So if an angle has a measure between 0 and 90 degrees, if an angle has a measure between 0 degrees and 90 degrees, then it is acute. Okay? A lot of times while we're doing these statements, we're going to be asking you what is the validity of that sentence. Anytime you're asked what is the validity, that's just is it true or is it false? Is it valid? Yes. Is it valid? No. Okay, so true or false. What is the validity for this sentence? If an angle has a measure between 0 degrees and 90 degrees, then it is acute. Is that true or false? That's true, right? What if I flipped it around? We don't have to, but what if I had written it, could I have written it, if an angle is acute, then it has a measure between 0 degrees and 90 degrees. Yeah, and that's still true, right?
Yes.
It's still a true statement. So it works either way. Okay, so you could have written this one either way, and it is a true conditional. Notice we use the word it over here. It's okay to be vague in the second half of the sentence, but make sure in the first half of the sentence we're always super specific. So we wouldn't say, if it has a measure between 0 and 90 degrees, then it is acute. Because if I use it in both sections, I don't know what we're talking about, right? I don't know what we measured. Okay? All right. B, x equals 4 implies x squared equals 16. How could I rewrite that as an if-then statement? Yes?
If x equals 4, then x squared equals 16.
That's perfect. If x equals 4, you can have expressions in sentences. If x equals 4, then x squared equals 16. What is the validity of that sentence? It's true, right? If x is 4, then x squared, 4 squared, does equal 16. What if I had flipped this? If x squared equals 16, then x equals 4. Would it be okay to write that?
Yes.
Yeah, it would be okay to write that. Is that also a true statement?
Yes.
Trick question. But wait, couldn't x also be negative 4 then? Because negative 4 squared is also a positive 16. So when I flip it around, I could find a counterexample that proves the sentence false. Right? That doesn't mean it's a bad conditional statement. It just means it's a false conditional statement. So things can be false, but still be good, if that makes sense. It's weird, I know. Okay? All right, let's look at the next one. A polygon with 4 sides is a quadrilateral.
If a polygon has 4 sides, then it's a quadrilateral.
Perfect. If a polygon has 4 sides, then it is a quadrilateral. If you're ever not sure in a sentence, I would try, actually, I know you're going to feel silly if you do it, but I would try actually just saying it out loud, even just kind of checking with the rest of the people I'm sitting with. Hey, does this sound right? Because sometimes you write something on paper and it's fine, and then as soon as you say it out loud, you're like, wait, I don't think that's right. Because I get a lot of sentences like, if it 4 sides polygon, then quadrilateral. Like, I get weird sentences that don't, when you say them out loud, don't really always make sense, right? So say it out loud and see if it makes sense. You should never have a they word in the first half, like an it or a they or a their. Okay, so if they are congruent, then they have the same measure. Well, that's not a good sentence because what are they, right? Are they segments? If the segments have the same measure, then they are congruent. Are they angles? If the angles have the same measure, then they are congruent. Are they rectangles? If the rectangles have the same measures, then they are right? So I need to know, what are they, right? So make sure, especially in the first half of the sentence, you're always specific. Then in the second half, it's okay to refer to them as they or it or whatever. Also try to stay consistent. If you're talking about if segments are congruent, so I'm clearly talking about more than one segment, so I shouldn't say then it has equal measures, because there's 2 segments, so they have equal measures, right? Try to stay consistent. Again, if you say it out loud, sometimes you'll hear when it sounds wrong. Okay? All right. Vocabulary. We have 2 important words for the next few days. First one, just like in science, we have a hypothesis, and then we'll have a conclusion. Your hypothesis is the if clause of a conditional statement. The conclusion is the then clause of a conditional statement. Okay? So, here is where if I have my 2 color pens, I'm going to assign one color every single time to the hypothesis. And if I just have a multicolored pen, I'm going to just underline my hypothesis in that color each time. If I have a highlighter, I can highlight that piece each time. Okay, so again, if I have a pen that I'm going to use, I can just underline my conclusion in that color each time. If I have a highlighter, then I can highlight my conclusion each time. Okay? All right, so from the conditional statement in the first example, if 2 angles are a linear pair, then they are supplementary. For my hypothesis, it's the if clause of the conditional statement. Okay? So it's everything between the if and the then. 2 angles are a linear pair. When you write the hypothesis all by itself, it should make a complete sentence. You should be able to understand exactly what we're talking about. I'm talking about 2 angles here, and I know what they're doing. They're being a linear pair. I've got my subject, I've got my verbs, I've got what they are, right? I've got all the things to make a sentence. 2 angles are a linear pair. Okay? My conclusion is everything after then. So in the sentence, it's they are supplementary. if I'm asked to write it by itself, it needs to be able to stand alone and be understood. So if I just say they are supplementary, I don't know what that means, because sometimes you're given a textbook and then that textbook comes with the supplement. That supplement is supplementary to the textbook, right? So if I look at the sentence, I know that they is referring to what? The two angles. So when I write the conclusion, when I'm asked on a worksheet or an assignment to write the conclusion to identify it, I need to make sure I identify what the vague words are. So we know we're talking about the two angles for the they, right? So the two angles are supplementary. Okay. So if I say something like, if an animal is flying, then it is a bird, right? An animal is flying is my conditional statement. But I wouldn't say it is a bird. What would I say for the second one?
The flying animal is a bird.
And we don't even really need to say the flying animal. We just need to say the animal is a bird, right? So if an animal is flying, the animal is a bird, right? So something like that. I know it's not a very mathy example, but sometimes it's harder to find mathy examples. Okay? So then this part right here is kind of important. It says, notice the words if and then are not written as part of the hypothesis and the conclusion. So the word if and the word then are not written. I didn't say my hypothesis is if two angles are a linear pair. It's just, I'm going to start with these two angles are a linear pair. That's what I'm starting, right? And then my conclusion is, what's the result? These two angles are supplementary. Okay? I don't write the if, I don't write the then. Okay? And then each one is written as a complete sentence. So, no vague words. I need to talk to an English teacher and see if there is one word that, like, what all those it's, theys, thems, theirs, he's, she's. Is there a word that means all of those? What is it? Pronouns?
Well, not it.
Yeah, I don't know that it would work with that. But we know what I'm talking about, right? Unspecific words.
Yeah.
All right, so sometimes we do this with math equations. And remember, an equation is a sentence, right? Because if I read this as a sentence, it's a complete sentence. X is equal to negative 3. That's a complete sentence, right? This is a complete sentence. 3 times x plus 2 minus 1 is equal to 5x plus 11. Okay? So when I look at this, remember, we're not going to include the if. My hypothesis is going to be just everything between, not including, the if to the then. And you don't have to write it out in English like a sentence. If we're in math class, you can absolutely just write 3 times x plus 2 minus 1 equals 5x plus 11. And what's my conclusion? X equals negative 3. That's a sentence. Okay. Question? Okay. Let's do some more examples. If x plus 7 equals 10, then x equals 3. What's my hypothesis? X plus 7 equals 10. What's my conclusion? X equals 3. Okay. Remember, a counterexample is a specific example that proves a conjecture false. Okay, it's not a justification, it's not an explanation, it's just a specific example. On some of the assignments I've been grading that I've been looking at, where you've been asked to provide a counterexample, some of you are writing these long discussions about why two adjacent angles don't have to be a linear pair. When you could just draw two adjacent angles that aren't a linear pair, right? It just needs to be an example, okay? It doesn't have to be an explanation. Same thing when you're asked to come up with a conclusion or a conjecture. You don't have to give a long dissertation. One of the problems on, I don't remember if it was yesterday or the day before, said B is the midpoint of AC. AB is 5, right? Or come to a conclusion about BC and AC. And some of you wrote me this beautiful paragraph about because B is a midpoint, that means it divides the segment into two equal pieces. So if one side is 5, then the other side is 5. So therefore, I know BC must equal 5. And if both sides of the segment equal 5, then using the segment addition postulate, I can do 5 plus 5 equals 10. So I know AC equals 10. And that was perfect. You got all the points you could get for that problem. But I just asked you to write a conclusion. I didn't ask you to explain or justify. You could have just said BC equals 5, AC equals 10. Move on to the next problem. So some of you are giving me these long dissertations, which is fine, but sometimes just read what the question is asking for. Okay? Some of you are working harder than you have to. All right, so let's look at these. Number 1, here's a false conditional statement. So I already know it's not true. If two numbers are odd, then their sum is odd. Okay? What is my hypothesis?
Two numbers are odd.
Two numbers are odd. Without the if, right? Two numbers are odd. What's the conclusion?
Two numbers sum is odd.
Thank you for not saying their sum is odd. Who didn't say their sum is odd? What is it?
Two numbers sum is odd.
The two numbers sum is odd, right? Because what is there? The two numbers. Okay, the two numbers sum is odd. All right, so next I need a counterexample. So here's what we need to do when we're doing a counterexample. The hypothesis has to be a true fact. So when I'm doing my counterexample, I have to start with a correct hypothesis. So I really do need two odd numbers.
77 plus 1.
Which ones?
77 plus 1.
77. And then you said 1?
Yeah.
Does that disprove the conclusion?
Yes.
No.
Is there some odd? No, what's their sum?
78.
78, which is
Even.
even. So the numbers 77 and 1 are a counterexample to this sentence. Does that make sense? Okay. And I don't have to write out an explanation that their sum is 78, so it's even, which disproves, right? I just have to say 77 and 1. Okay? All right, so here's what we're going to do is these practice problems. Number 2 says finish the following conditional statement so that it will always be true. If an angle is named angle ABC, then what's something we know is true about that angle? That point B is the vertex, right? So I can say if an angle is named angle ABC, then point B is the vertex. Do you think that's the only way I could have finished that sentence?
No.
What else do we know about angle ABC?
There's the points are ABC.
I don't know if I go with the points or ABC. That's not very specific.
Angle ABC, then angle ABC has ray AB and ray BC.
Then the angle has ray BA and ray BC, right? The sides are ray BA, the sides are ray BC. How else could I name angle ABC? Angle CBA, right? I could say if an angle is named angle ABC, then it could also be named angle CBA, right? So a few different. I don't know that I could name it just angle B, right? Because I don't know how many lines are coming out of B. So I don't know how many angles are at point B. But I can go with B as the vertex. I can name the sides, or I could rename it with the opposite order of the letters. Okay, those would all be good sentences, but I only needed to do one. Number 3, write a true conditional statement that has the conclusion, the angles share a vertex. A true conditional statement that's going to end with the angles share a vertex. What kind of angles share a vertex? Which ones? Adjacent. Are there any others? Linear pairs. Are there any others? Vertical. So you can use any of those. You could say if angles are adjacent, then they share a vertex. If angles are a linear pair, then they share a vertex. If angles are vertical, then they share a vertex, right? All of those statements would be a true conditional statement. So if angles are, I think the first thing I heard was adjacent, so we'll go with that. But you could put linear pair or vertical here. Then they share a vertex. Now, it did say that my conclusion is supposed to say the angles share a vertex, and in the conclusion it says they share a vertex, but is that they referring to the angles?
Yes.
Yes. So we're okay there. But if I was asked to write this by itself, I would need to say the angles, right? All right, number 4, write the definition of collinear points as a conditional statement. How could I write collinear points as a conditional statement?
If 2 points are stated, then they're collinear.
If they're what? What does it mean to be collinear?
Streets are on the same line.
On the same line. So if points are where? Then they're what? Oh, couldn't we just say that?
And
If
2
points are on the same line. Does it tell us we have to say how many points? No, because 3 points can be collinear, 4 points can be collinear, 7 points can be collinear, right? So just if points are on the same line, then they are collinear. If points are on the same line, then they, or the points, are collinear. Could I switch that around and said if points are collinear, then they lie on the same line?
Yes.
Yeah, absolutely. And either way I would have written it, it would have been true. The validity would have been true. Okay? All right, number 7, determine the validity of each conditional statement. So I just reminded you, hopefully you remember because I just said it, that the word validity is just asking, is it a true statement or is it a false statement? If false, give a counterexample. Remember, we're going to assume the hypothesis is true and say, does the conclusion have to be true also? So if you have $5, so we really do have $5, that's true. That means we have to have 5 $1 bills. True or false? False. Give me a counterexample. I could have one $5 bill, right? Or 500 pennies. Or 4 $1 bills and 4 quarters, right? We only have to give how many counterexamples? One, so whichever of those is your favorite. I like, you could have 500 pennies, because that one's fun to me. I wouldn't want to have 500 pennies, though. That's a lot of pennies. I know. You could have 500 pennies, you could have one $5 bill, you could have 2 $1 bills and 12 quarters. You could have 50 dimes, right? So any counterexample you want to give. All right, the next one. If I roll 2 6-sided dice and the sum of the numbers is 11, then one of the die must be a 5. If it's false, I need a counterexample. Oh, it's true, right? There's no 2. The only way, remember, dice only go up to 6, right? They have 1, 2, 3, 4, 5, and 6. To get an 11, you'd have to add a 1 and a 10. Well, there's not a 10 on the die. You'd have to add a 2 and a 9. There's not a 9 on the die. A 3 and an 8. There's not an 8. A 4 and a 7. There's not a 7. So 5 and a 6. would give me an 11. And so it has to be a 5 and a 6. There's no other combination that would make 11. That you also have the die. So one die does have to be a 5. So this is true, and I'm done. I don't have to write all that explanation I just came up with. I just have to say it's true, because it only says if false, give a counter example. If two angles are supplementary, then one of the angles is acute. True or false? I'm hearing a couple of falses, which means there must be a counterexample. What's my counterexample? 2 90-degree angles. Or 2 right angles. So false. Do you want to draw that, or do you want to write it out? Draw. Okay. I'm just going to do like this then. Those 2 angles are supplementary. They're both 90. Notice I had to put the little boxes in the corners so I could show they were 90. Or you could have drawn them separately, or you could have written out 2 90-degree angles. That's all we have to do, though. We don't have to do an explanation or a justification. We just have to give the counterexample. Okay? Any questions? All right, your assessment is in Schoology for today.